So the distribution function. So probability of x less than or equal to x is called what is that? Probability of event of x less than or equal to x. So it depends on what? It depends on x only. So we denote it as fx of x. What is fx of x? Is nothing but cumulative probability distribution function of a random variable x. So fx of x is equal to probability of x less than or equal to x. So fx of x is a distribution function of x, and x value will be ranging from minus infinity to plus infinity. Okay, so we fx of x, that is probability distribution function, will be having some of the properties. The properties are fx of minus infinity is equal to 0, fx of infinity is equal to 1, and fx of x will be having the value between 0 and 1. Fx of x1 will be less than or equal to fx of x2 if x1 is less than x2, and probability of x1 less than x less than or equal to x2 is given as fx of x2 minus fx of x1, and the sixth property is fx of x inverse is equal to fx of x. Okay, so these are the properties of distribution function. Now we'll discuss the proof of all these properties. What is the fx of minus infinity will be equal to 0. So what is fx of minus infinity? It is equal to probability of x less than or equal to minus infinity. So since we don't have any event with x less than or equal to minus infinity, so less than or equal to minus infinity is not possible, no? So we don't have any event. Okay, so this event is called impossible event. So the probability of x less than or equal to minus infinity will be equal to 0. So fx of minus infinity will be 0. Okay. So similarly, fx of infinity is equal to 1. So what is fx of x? Fx of x is probability of x less than or equal to x. So what do you have in the place of x here? In the place of x, we have infinity, no? So fx of infinity is equal to what? Probability of x less than or equal to infinity. So what is that we have to do? We have to add all the elements with the x less than or equal to infinity. So it is equal to probability of x is equal to minus infinity plus so on, probability of x is equal to minus 1 plus probability of x is equal to 0 plus probability of x is equal to 1, so on, till probability of x is equal to infinity. What happens here? It will include the complete sample space. So it is the probability of complete sample space. So what is the probability of sample space? The probability of sample space will be equal to 1. Okay, so if x is less than or equal to infinity means it will include all possible events. Okay, so that is the sample space. So what is the probability of sample space will be equal to 1. And just now the third property says that fx of x is having the value between 0 and 1. What is the minimum value of distribution function will be 0. The maximum value will be equal to 1. Okay. So just now we have discussed that what is fx of minus infinity? Minus infinity is equal to 0. This is nothing but the minimum value. Fx of infinity is equal to 1. So that is the maximum value. So the value of fx of x will lie between 0 and 1. Okay. And the fourth property says that if x1 is less than x2, if x1 is less than x2, fx of x1 less than or equal to fx of x2. Okay, it means that fx of x is non-decreasing function. It is increasing function. Okay, so when x1 is less than x2, what happens here? The events can be represented by probability of x less than or equal to x2 will be greater than or equal to x less than or equal to x1. What is given? It is given that x1 is less than x2. So here is your x1, here is your x2. Okay, so say for example, okay, this is our starting point. Number of elements till x1 will be less than number of elements till x2, no? So you will be counting number of elements till x1. will be less than number of elements till x2. So x is less than or equal to x2 will be always greater than or equal to x is less than or equal to x1. Okay, so number of elements till x2 will be always greater than the number of elements till x1. Okay, now we are finding the probability. So since it x2 till x2 will be having more number of elements, the probability of x less than or equal to x2 will also have higher probability compared to probability of x less than or equal to x1. So probability of x less than or equal to x2 will be always greater than or equal to probability of x less than or equal to x1. Okay, so from this we can say that fx of x2 will be always greater than or equal to fx of x1. Fx of x2 will be always greater than or equal to fx of x1. So the fifth property says that probability of x1 less than x less than or equal to x2 will be equal to fx of x2 minus fx of x1. So we know that what is x less than or equal to x2. You please take this example here. The sample space is defined like this. It is the having the values 0, 1, 2, 3. Say x1 is at 1, x1 is at 1 and x2 is at 3. Now for x less than or equal to x2, x less than or equal to x2, how do we define? X less than or equal to x1, x less than or equal to x1, then x1 less than x less than or equal to x2. We are dividing this into two parts. So the first part will be having the elements only till x1. The second part will have the elements from x1 to the last x2. Okay, so like that the union of this will give us the complete elements till x2. So x less than or equal to x2 will be x less than or equal to x1 union x1 less than x less than or equal to x2. Okay, so now if you apply the probability to this, probability of x less than or equal to x2, probability of x less than or equal to x2 is nothing but fx of x2. Probability of x less than or equal to x1 is nothing but fx of x1. Okay, and because it is union, we are adding these two. We are using our third axiom, union of two mutually exclusive events, because it is mutually exclusive, no, till here and from here to here it does not have common elements. Okay, union probability of union of two mutually exclusive events will be equal to sum of the probabilities of individual events. Okay, so that is why we'll be getting probability of x less than or equal to x1 will be equal to what? Fx of x1 plus probability of x1 less than x less than or equal to x2. So from this relation, from the second relation, we will be writing it as probability of x1 less than x less than or equal to x2 will be equal to fx of x2 minus fx of x1. This is our fifth property. So the sixth property says that uh, it says that the distribution function is the continuous function. Okay, so if you want to check any function to be probability distribution function, what is that? We have to check whether the property 1, 2, 4 and 6 are satisfied. If these properties are satisfied, then we say that the given function is valid distribution function. So what is the property 1? Property 1 says that fx of minus infinity is equal to 0, fx of plus infinity is equal to 1, and what is our fourth property says, if x1 less than x2, then fx of x1 should be less than or equal to fx of x2. That is our fourth property. And sixth property says that the cumulative distribution function should be continuous function. If these four conditions are satisfied, then we say that the given function is valid distribution function. Okay, so for example, if x is a discrete random variable, if capital X is a discrete random variable, then fx of x have state step form as shown in the figure. Okay, so amplitude of step will be equal to the probability of occurrence of the value x where the step occurs. Okay, so if the value of x are denoted as xi, then see here we can have fx of x will be having state step waveform. Okay, here how much it has to rise? It has to rise by the probability of the event which is occurring at x is equal to minus 0.5. So it means that we are getting we have the events at minus 1, minus 0.5 and 0.7, 1.5 and 3. At these points we have the probabilities. Okay, so how much it will be raised here? It will be raised by the what is the probability at that particular location. Okay, so here also it is raised means there is some probability at the event x is equal to 0.7, so that it is raised by that. Okay, so like that we will be getting stage step waveform for distribution function. Okay, how do we denote this? This denoted as fx of x is equal to summation I is equal to 1 to n p of x is equal to xi u of x minus xi. Okay, this is the formula we use to denote the distribution function for discrete random variable. Now in this case, what is u of x? U of x is nothing but unit step function. Okay, u of x is nothing but unit step function. What is unit step function? U of x is equal to having the value 1 when x is greater than or equal to 0, and it is having the value 0 for x is less than 0. Okay, so we also know that what is probability of x is equal to xi? Probability of x is equal to xi is also equal to probability of xi. So instead of representing probability of x is equal to xi, we can directly denote it as probability of xi. So what is the distribution function now? See here, fx of x is equal to summation I is equal to 1 to n p of xi. So instead of having p of x is equal to xi, we have p of xi u of x minus xi. Okay, so this is the relation we will be getting for distribution function. Okay.